Hello again, physicists. Today's video we are going to compare and contrast the Coulomb force to the force of gravity. These are both what we would call two of the four fundamental forces of the universe. And because of that, these two forces have some things that are in common with one another and other things that are importantly different. And these two forces dictate a lot of the interactions that we observe in our universe. So we're going to compare and contrast them on three different criteria. The first one being the mathematical models that describe how these forces will interact, what they depend upon. Then we're going to look at their relative strengths. So we're going to actually calculate the force between two objects, both their Coulomb force and their force of gravity, and see how do the forces compare to one another when all things are the same. And then lastly, we're going to talk about and consider the direction in which these two different forces can exert themselves. So, to begin with the mathematical models that we use to describe them, I'm going to put everything for the Coulomb force on the left-hand side and everything for the force of gravity on the right-hand side. For the Coulomb force, the equation that we have to describe the Coulomb force is as follows. The magnitude of the Coulomb force depends upon the electrostatic constant multiplied by the two charges with which this force is being shared divided by the distance between those charges squared. And then for the force of gravity, as you recall when we did Newton's law of gravitation, the magnitude of that force is equal to the universal gravitational constant multiplied by the two masses with which the gravity is shared divided by their distance squared. So right off the bat, there are a couple of things that you should notice. First off, both the Coulomb force and the force of gravity have the same dependence upon distance. They follow what we call the inverse square law, where at very, very close distances, gravity and Coulomb force would both be very strong, and at extreme distances, they would both be fairly weak. The second thing has to do with the fact that you need two of something in order for each of these forces to exist. In the case of the Coulomb force, you need to have two charges. And in the case of gravity, you need to have two masses. And then the final thing is this constant of proportionality. In both cases, there is some inherent fundamental constant that has to be incorporated to accurately describe both the Coulomb force and the force of gravity. For the next part, to determine the relative strengths, we're going to actually calculate the Coulomb force and the force of gravity shared between the same two objects, a single proton and a single electron. So that means for the Coulomb force, we would find that force by taking the electrostatic constant. And forgive me for not using my units. I am doing this just because of limitation as far as space goes. So we have our electrostatic constant, and then both the electron and the proton will have the same amount of charge on them since they are elementary charges. And we are going to say that the distance between these two things is exactly 1 meter. So it'd be over 1 squared. And after doing some number crunching, we can then determine that given all these conditions, the Coulomb force between a proton and electron that are separated by 1 meter would be about 2.3 times 10 to the minus 28 newtons. That's times 10 to the minus 28 newtons. A very small amount of force. But remember, we're comparing this to the force of gravity. So let's see if gravity, given these same conditions, will be stronger or weaker than this value right here. So for the force of gravity, I would find that by using the universal gravitational constant. and then we would multiply by the two masses, which in this case would be the mass of a single proton and the mass of a single electron. Now, forgive me for not writing those in, because sure enough, I have run out of real estate. You'll just have to take my word on this. If I put in the mass of a proton and the mass of an electron, and again divide by 1 meter squared, since that is still the distance between them, I would get the gravitational force to work out to be about 1 times 10 to the minus 67 newtons. So what that is telling us is that the force caused by electrostatics, or the force called the Coulomb force, it is way, 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 way stronger than gravity. Way stronger. Given all the same conditions, pound for pound, the Coulomb force is stronger than the force of gravity. In fact, gravity is the weakest of the 4 fundamental forces in our universe. All right, and then for the last part, let's think about direction. So keeping with my proton and my electron, I know that the electrostatic force in this case would attract them towards each other. And the force of gravity would do the exact same thing. So both gravity attracts and the Coulomb force attracts. But let's change it up. What if I replace my electron with a proton? Well, now I will not have a force of attraction, at least when it comes to the Coulomb force. Instead, the two protons would want to repel one another. But they would still be attracted due to gravity. So the Coulomb force is kind of a two-way street, where this force can attract or repel the two objects of interest, whereas gravity will only attract. So there it is, a compare and contrast between the Coulomb force and the force of gravity. Until next time, physicists, until next time.